Welcome, students. This is our video notes for graph interpretation. We're just going to spend some time on independent and dependent variable. This is for Thursday, October 9th. It's going to be our second lesson here in the second 6 weeks. Alright, these are a couple of new words here. Discrete graph is disconnected points. So a discrete graph is going to just be dots like this around the screen. Continuous graph is a graph with connected points. So you still might have the dots, but there will be a line that goes through and connects them. Okay, so that's the difference between continuous and discrete. We already know that the independent value belongs on the x-axis. We've been studying that for a while. Independent is x, and the dependent variable is the y-axis. And the phrase we gave you in class to help you remember that is y am I so dependent on my x. So y is dependent. Why am I so dependent on my x? Okay. This is kind of the how-to as far as how to interpret graphs. Where do we start? We read the graph from left to right, just like we're reading a book. We interpret the graph in segments, so we look at certain segments. We look to see if those segments are increasing, decreasing, or being constant. Increasing means that it slants upward, and it can increase at a slow rate, which would be slow and steady, or it can increase at a fast rate, which would be steep like that. Slants downward, does it go down from left to right? And then does it decrease at a slow rate, or does it decrease at a fast rate? So that all has to do with how steep it is. Constant just means that it's going to be a flat line, and there's no rate of change, so it's going to look like this, flat. Be sure to look at the axes and what the labels are on those when you're trying to interpret a graph, so you know whether you're looking at speed or time or distance or what's in each one. Alright, rate of change. On this first graph here we have time versus distance. So our independent variable is our x, which is time, because this is always x and this is always y. So this is our time, and this is our y, which is distance. What does the straight line indicate about the rate? Okay, so if we look at our rate, this is going which direction? It's going up, so our rate is increasing. Okay, and it's just increasing kind of at a steady rate. This would be faster, this would be slower. Okay, so we don't know exactly what kind of rate this is, but it's a very steady rate there. Okay. The next one here, again our x and our y. Our x is going to be time, our y is going to be distance, so time versus distance. What does the shape of the graph indicate about the rate here? It starts off a lot faster, and then right around this point right here it starts to even off and go slower. So our rate starts fast and then it kind of evens off, and by evens off I mean it kind of slows down. It's not completely stopped because it's not flat, but it's evened off a little bit. Here again, our x is our independent, so that's time, and our y is our dependent, so that's our distance. And this time we're asking a little bit different question. How does the rate of A compare to B? So when we look at A and we look at B, B is a much steeper line than A. So the rate A is a slower rate than B. And we could also say B is a faster rate. This one is more concerned with the starting place or the initial value, or what's going to be later known in the year as the y-intercept. You'll see that this one starts down here at the bottom. Time is still our x, y is our distance. So that's our independent and our dependent. This is the origin, so our starting point is 0, 0. And so that means at 0 time, so this could be minutes or hours or something like that, we've gone 0 distance. Okay? And so this could be the graph of you going someplace. So as you start to drive, your distance gets further and further away from where you started, further and further away from home. Okay. This one we can see starts further up the graph here. So again, our x and our y, our x is time, and our y is distance again. And this starting point, we don't really know it, but we could say that's 5, 10, 15, 20. And so this time our starting point would be 0, 10, according to the way I labeled the graph. And the way this graph is set up is we're 10 miles from home, and we are driving towards it. So we're 10 miles from home and we're driving towards it. So you can see as time passes, we get closer and closer to home. And so we can get down right here to here, this will be home. Okay? We were further away from home. As time passed, our distance towards home got closer.